Hi, and welcome to the videos for 2.6 of Math 126. This is the first of two videos. In these videos, we're going to look at combining functions. That's what section 2.6 is. And in this first video, we're looking at the algebra of functions. So addition, subtraction, multiplication, division. In the second video, we're going to be looking at composition of functions. And what we're really going to be worried about here is the domain when we do this combination of functions. So first, let's look at the various definitions. So algebra of functions. So you may want this on your cheat sheet if you're an instructor. I do. If your instructor allows you like a note sheet or a note card, this might be something you want on there. But we're going to start, let f and g be functions with domains A and B. So the domain of f is A. The domain of g is B. So first, if I add two functions, so f plus g of x, this is just take the f function, add the g function, and the domain of these two is going to be the intersection of their domains. So if g is a square root function and f is a fraction function, we're going to have issues with what values we can pick for g, what values we can pick for f. The domain, if we add them together, is the intersection of those two domains. So remember in earlier videos in chapter 1, we were talking about like finding intersections of sets. That's basically what we're doing. We have set A, set B, what's its intersection? If we have f minus g of x, this is just the function f of x, because f is listed first here, that's what's listed first, minus g of x, and again the domain is A intersect B. 3, if I have multiplication. So if I multiply two functions together, I just multiply the individual functions, and again, the domain is the same. The intersect A, intersect B. And where it gets tricky is when I have division. So if I'm dividing f by g to get a new function, that's f of x divided by g of x, but the domain, we have to be careful here. So now the domain, and it's this funny notation, but I'll verbalize it out for you here. It's any value x, and we have this notation which means is in the set. So x is in the set A intersect B, so it's still, that's the same. We have this line here which means such that g of x cannot be 0. So g of x by itself could have been 0 if we plugged in one of its values, but now it can't be 0 because that's in the denominator. So we need to be careful. So our domain, if we divide two functions, is what all this means is it's the intersection of A and B, the same intersection of the domains, but it can't include any value that would make the function g equal to 0. So let's look at an example here. I'll leave that for now. So let f of x equal 1 over x minus 2, and g of x is equal to the square root of x. So we want to find f plus g, f minus g, f times g, and f divided by g. And then we also want f plus g of 4, f minus g of 4, f times g of 4, and f divided by g of 4. So this just means what? Once we find what these functions are, we just plug in 4 for our value of x. So we want to have these domains. So for f, my domain A is what? Well, it's any value of x as long as x doesn't equal, not 0, x doesn't equal 2. I can't have x equals 2 because that would make that undefined, but any other value is fine. And how about for g? Well, the domain B is what? X has to be greater than or equal to 0. So f plus g, so actually we want to find all this. So find all these and list the domain. So f plus g. So that's what? That's just adding the two functions together. There's nothing tricky about it. It's just 1 over x minus 2 plus square root of x. So the domain for this combined function is what? Well, my f of x is everything from negative infinity up to 2 and then up to positive infinity. For g, it's everything from 0 up to positive infinity. So the intersection of this is what? Everything from 0 to infinity, but not including 2. So that's what? That's 0 up to 2 with a parenthesis, union 2 up to infinity. So that's my domain here. 0 up to 2, union 2 up to infinity. So even though I could have had negative values for the function f, because I'm combining these, I'm now restricted to whatever the intersection of these functions are, which is 0 up to 2, not included, 2 up to infinity. How about f minus g? So same idea, it's just now I put a minus sign. So it's f minus g. And again, I'll put the little hash marks there, the tick marks. Same domain. When I add, subtract, or multiply, it's the same domain always. F times g, well, it's just these two multiplied together. So 1 over x minus 2 times square root of x, which is just what? Square root of x over x minus 2. And again, the domain is the same. And now f divided by g. So this is what? This is 1 over x minus 2 divided by square root of x. So if I simplify this, keep, change, flip, I get 1 over square root of x times x minus 2. But my domain is what now? The domain is the intersection, but g of x cannot be 0 now. So before, it could have been 0. That was fine. It was just square root of x. If it's 0, square root of 0, that's fine. But now 0 can't be included. So how does that change this? Well, now it's 0 with a parenthesis up to 2, union 2 up to infinity. So that's the difference here with the domain, is that I'm no longer including 0 because it's 0, g of x cannot be 0 because it ends up in the denominator. So now I want to figure out these values when I plug in 4 for x. So that was part 1. Part 2. If I plug in 4 into the sum, I get what? 1 over 4 minus 2 plus square root of 4. 4 minus 2 is 2, so that's 1/2 plus square root of 4 is 2. So this is like 4 over 2. So that means my answer would be 5/2, simplified as far as I can go. The difference, so it's still 1 over 4 minus 2, but now it's minus square root of 4. So it's 1/2 minus 4 over 2, or 2. So this is minus 3 over 2, or negative 3/2. The product, when I plug in 4, is this third one here. So it's the square root of 4 over 4 minus 2. Square root of 4 is 2. 4 minus 2 is 2. 2 over 2 is 1. And then the quotient, if I'm dividing it, it's 1 over square root of 4 times 4 minus 2. So it's 1 over square root of 4 is 2 times 4 minus 2 is 2. 2 times 2 is 4. So it's 1/4. So that's it. That's the algebra when we are combining functions. Addition, subtraction, multiplication, division. We have to be careful. The domains are always the intersection, but with our quotient we have to make sure g of x is not equal to 0. So that's it. Come on back and we're going to look at the composition of functions.